Hello everyone, in this video we are going to solve problem 294, problem 94 of chapter 2 of your textbook. So the problem is saying that the force B is 700 Newton, force C is 560 Newton. Determine the magnitude and coordinate direction and angles of the resultant force acting on the flag point. So we have this flag point and two forces are being applied by these two ropes on our system. And like many other static problems, we want to find the resultant force, the combination of the two. But because forces are vectors, we can't simply say that 700 plus 560, that would be our resultant force. So our vectors, and we need to use vector summation. We talked about two-dimensional vector summation. You could use a triangular or parallelogram rule for two-dimensional vectors, but for three-dimensional, it becomes really challenging if you want to use that rule. So Cartesian would be the best way to go. And we have to change these vectors. We have the magnitude. We need to write them in Cartesian form. If we had the direct angle, we could simply write the cosine of each angle to each axis and find it in Cartesian form. But we don't have the angle either, but we have the dimension. So we have to use the unit vector definition to find each forces in Cartesian form. That means that the force FB, if you want to write it in a vector form, you have the magnitude of FB, which is 700, times the unit vector, the direction. That gives us the Cartesian component. Similar for FC, would be 560, and the direction, right? Arrows indicating vector. So our first task is to find UB and UC. So looking at the problem, UB, this vector is going from A to B. So UAB, we can call it UAB. And to find the unit vector, we can find a position vector and divide it by its magnitude. That would give us the unit vector. So UB would be simply RAB divided by its magnitude. Why did we write RAB and not RBA? Because our vector is going from A to B. The position vector RAB, how can we find the position? Is the coordinate of B minus the coordinate of A. We have the coordinates here. So RAB would be 2I negative 3J minus 6K. Magnitude, each component squared. So 2 squared would be 4 plus 9 plus 36. So a negative value squared would be the same as positive. So 2I, which means that from A to B, I'm going towards positive X is to negative 3J. So Y, I'm going towards negative Y, negative 3J. And 6, I'm going down in Z axis, so negative 6K. So you can see directly how the coordinate is changing from A to B. Or if you are more comfortable, you can write the coordinate of B minus the coordinate of A. So that gives me, if I simplify this, 2 over 7I negative 3 over 7J and negative 6 over 7K. IJK. Can you tell me what is the unit of the unit vector? The unit for the position vector is meter. What is the unit for the unit vector? Yes, you guessed it right. It's unitless because we divide meter by meter. Some people like to refer it as meter by meter, or we can call it a unitless because it only tells us the direction. The next task is to find the unit vector C. C is going from A to C. So UC, we can also write it as UAC. How to find it? Position vector divided by its magnitude. That's the definition of unit vector that I talked about in the previous video. If you write our AC into 6's, and do the same procedure here. AC is 3i, 2j, 6k, divided by its magnitude. 9, 4, 36. You can see the denominator is the same as the previous one. So we know that would be 7. So 3 over 7i, positive 2 over 7j. I'm going to write the third component here, negative 6 over 7. Okay, that's the unit vector for B and C. So why did we find the unit vector? Because we wanted to multiply by the magnitude and find these two forces in Cartesian form. Because if they are in Cartesian form, then we could simply add them together. Now I can tell that FB is 700, the magnitude. Now I want to change it to the direction. So that would be 2 over 7. I found it up there. Negative 3 over 7j times negative minus negative 6 over 7k. That gives me FB 200i minus 300j minus 600k. So now I have my vector in Cartesian form. What's the unit Newton? I can do the same thing for FC. I have 560, that was the magnitude. I multiplied by the unit vector to find a vector in Cartesian form. Therefore, I have FC 240i plus 160j negative 480. Okay. The unit is Newton. Now the question is asking for the resultant force, FR. Now I have both of them in their component form, so I can simply add them together. We said that each component is a scalar, so I can add the components. And if I do so, I have 440i minus 140j minus 1080k. It's a force, so the unit is Newton. I just added the component together. I added 240. Here, this component to 200. Same thing for other components. Now I have the resultant force. I can find a magnitude because the problem is asking for the magnitude and coordinate direction. So finding a magnitude, by now you should be confident in finding the magnitude of a vector. Each component squared, and then we take the square root of all of them. Again, when it is, you don't have to write a negative sign, it won't make a difference. Value that I found is 74.56. That's the magnitude. If I want to find the coordinate direction, cosine alpha would be the x component over the magnitude. The x component here is 440. The magnitude is 74.56. Remember, the magnitude is always positive. Therefore, alpha would be 68 degrees. I do the same thing for beta and gamma. For beta, here in the numerator, you have the y component, which is here negative 140. And for gamma, you're using 1080, negative 1080. So beta would be 96.8 and gamma would be 157 degrees. So now we have the answers. These are the coordinate direction angles, alpha, beta, and gamma. The angle of the resultant vector with each axis. Also, this one is the magnitude.